Hello, welcome back. Today I want to talk about the differences between observational studies and experiments. So this is something you might have heard about in the news when they're talking about deciding whether a medicine or vaccine works, right? You might have heard the terms observational studies and experiments. So let me first read the first sentence in these examples here. So the first example, researchers wanted to determine whether there's an association between mobile phone use and brain tumors. The second one, researchers examined whether chronic exposure to radio frequency radiation at two common cell phone signals, 835.62 megahertz, a frequency used by analog cell phones, and 847.74 megahertz, a frequency used by digital cell phones, caused brain tumors in rats. Both of these examples are asking similar questions. Right? They're both asking does something affect something else? Both of these examples are asking, does cell phone use affect brain tumors? The first blank is usually called the treatment variable. And a second blank is usually called the outcome variable. So we're asking, does the treatment variable affect the outcome variable? One of these is an observational study, and the other one is an experiment. So what's the difference? In an experiment, you, the researcher, controls who gets the treatment and who doesn't. Right, so you have your group of people. You're going to break them up into two groups. One group you give the medicine or the treatment to, and the other group, the non-treatment group, you give a placebo, a fake medicine. And you get to choose who's in the treatment group and who's in the non-treatment group. In an observational study, you're not doing that. You're only observing or measuring. Without controlling who gets the treatment and who doesn't. So in an observational study, the people are coming to you already in either the treatment group or the non-treatment group. Right? You're not deciding who gets the treatment and who doesn't. All right, so let's go back to the front page and decide whether the examples were experiments or observational studies. Both of these examples on the front page were asking, does cell phone use affect brain tumors? Okay, so let's read the rest of the example. To do so, 791,710 middle-aged women in the United Kingdom were followed over a period of 7 years. During this time, there were 1,261 incidences of brain tumors. The researchers compared the women who never used a mobile phone to those who used mobile phones and found no significant difference in the incidence of rate of brain tumors between the two groups. Question is this an experiment or is this an observational study? Okay, so the treatment here is cell phone use. And the question you should ask yourself is, did the researchers control who used cell phones and who didn't? Right? Did they tell people, okay, you people use cell phones and you people don't use cell phones? Or did the people already come to the researchers either using cell phones or not using cell phones? So in this first example, the researchers are not controlling who gets to use cell phones and who doesn't, right? The people came to the researchers already either using cell phones or not. So the first example is an observational study. The second example, which is asking same question. To do so, the researchers divided 480 rats into 3 groups. The rats in group 1 were exposed to the analog cell phone frequency. The rats in group 2 were exposed to the digital frequency. The rats in group 3 received no radiation. Okay, and then the rest. So the second example here, the researchers are breaking up the rats into 3 groups and then deciding which group got the cell phone frequency and which group didn't. So the second example is an experiment. So why is this important? This is important because in an experiment, right, because you get to decide who's in the treatment group and who's in the non-treatment group, you have an opportunity to make those 2 groups as similar as possible, with the one difference being that one group gets the treatment and one group does not get the treatment. So that's important because if you see any differences in the outcome, right, it can only be due to one thing, that one difference, that treatment. So in an experiment, you can conclude that the treatment is causing the difference in the outcome. Right, you can conclude that the treatment affects or causes the outcome. And this is different than an observational study. So in an observational study, you're not choosing who's in the treatment group and who's in the non-treatment group. The people are coming to you already in the treatment group or the non-treatment group. So those 2 groups might be different. And because they might be different, you don't know. If you see a difference in the outcome, you don't know whether it's because of the treatment or whether it's because of these other differences. So in an observational study, you cannot conclude. That the treatment affects the outcome. The best you can really do is to say that the treatment is associated with or is related to the outcome. And this is a weaker statement than saying that the treatment causes or affects the outcome. So in an observational study, because the people are coming to you already in the treatment or the non-treatment, those 2 groups might be different, right? And these differences are called confounding variables. So a confounding variable is just another variable other than the treatment that could affect the outcome. And as I said, these differences is something that you have to live with if you're doing an observational study. So confounding variables often occur in observational studies. So let me give you a concrete example of this. So say I'm studying whether smoking is related to heart disease, right? And I'm doing it as an observational study. So the people are coming to me already either smokers or non-smokers, right? I'm not choosing, okay, you guys smoke and you guys don't smoke, right? The people are coming to me already either smokers or non-smokers. So those 2 groups might be different, right? So the gender makeup of the smokers might be different than the gender makeup of the non-smokers, or the age distribution of the smokers might be different than the age distribution of the non-smokers. So if I see a difference in heart disease, I don't know. I don't know if it's because of the smoking or whether it's because of these other differences, the gender or age. So gender and age are examples of confounding variables. Okay, and this isn't an issue in experiments because in an experiment, right, I have control. I can choose it so that the two groups have the same gender makeup and the same age makeup, right? So that's not an issue anymore. Okay, so let's take a look at example 1. A medical researcher wants to determine whether exercising can lower blood pressure. At a health fair, he measures the blood pressure of 100 individuals and interviews them about their exercise habits. He divides the individuals into 2 categories, those whose typical level of exercise is low and those whose level of exercise is high. The subjects in the low exercise group had considerably higher blood pressure on average than subjects in the high exercise group. Can the researchers conclude that exercise decreases blood pressure? So first of all, let's talk about what the treatment and the outcome variables are. So what question are these researchers trying to answer? Does blank affect blank? Does exercising lower blood pressure, right? So does the level of exercise affect blood pressure? And the first thing we need to talk about is this an experiment or is this an observational study? So the question you should ask yourself is, did the researchers control who did low exercise and who did high exercise? So did they tell people, okay, you guys do low exercise and you guys do high level of exercise? No, right? So in this case, the people came to the researchers already in either the low exercise group or the high exercise group. So this would be an observational study. Okay, so because it's an observational study, can you conclude that exercise decreases blood pressure? No, right? So because it's an observational study, no, you can't conclude that exercise has an effect on blood pressure. So this is a no. Example 2. A medical researcher wants to determine whether exercising can lower blood pressure. She recruits 100 people with high blood pressure to participate in the study. She assigns a random sample of 50 of them to pursue an exercise program that includes daily swimming and jogging. She assigns the other 50 to refrain from vigorous activity. She measures the blood pressure of each of the 100 individuals both before and after the study. On average, the subjects in the exercise group substantially reduced their blood pressure, while the subjects in the no exercise group did not experience a reduction. Are the researchers justified in concluding that exercise decreases blood pressure? So what's the treatment here and what's the outcome? Okay, so the basic question that they're trying to answer is blank affects blank. So what affects what? Does exercising affect blood pressure, right? Right, so really the same treatment and same outcome as example 1, right? So exercising and blood pressure. Is this a experiment or is this a observational study? Okay, so question you should ask is, did the researchers decide who exercised and who didn't? Yeah, so here, yes. Right, so here she assigned 50 of them to swim and jog, and the other 50 to not do any vigorous exercise. Right, so they are deciding who is exercising and who is not. So this would be an experiment. Right, and because it's an experiment, yes, you can conclude that exercising affects blood pressure. So to answer the question here, are the researchers justified in concluding? Yes, they can. They can. Example 3. An agricultural scientist wants to determine the effect of fertilizer type on the yield of tomatoes. There are 4 types of fertilizer under consideration. She plants tomatoes on 4 plots of land. Each plot is treated identically except for receiving a different fertilizer. The yield differs substantially among the 4 plots. Can a scientist conclude that the differences in yield are due to the differences in fertilizer? Okay, what's the treatment and what is the outcome here? Okay, basic question that the scientist is trying to ask is, does what affect what? Does blank affect blank? Does the fertilizer type affect how much tomatoes grows? So the yield of tomatoes. Okay, question is this an experiment or is this an observational study? So did the scientist decide which tomatoes got which fertilizer type? Yes, right. So there's 4 plots of land, and then she decided which fertilizer each plot got. So she decided which fertilizer the tomatoes got. So this is a experiment. Okay, and because it's an experiment, you can conclude that the fertilizer type affects the yield of tomatoes. So to answer the question, can you conclude that the differences in yield are due to the differences in fertilizer? And it's a yes here. Example 4, in a study of people who suffered heart attacks, it was found that those who lived in smaller houses were more likely to recover than those who lived in larger houses. Does living in a smaller house increase the likelihood of recovery from a heart attack? Okay, what's the treatment here and what's the outcome? The basic question that they're trying to answer is, does blank affect blank? Does what affect what? Does the size of the house affect the likelihood of recovery? Okay, so is this a experiment or is this a observational study? So did the researchers decide which houses, the size of the house that these people live in? No. All right, so the people came to the researchers already either living in a small house or a big house. So the researchers here did not decide who lived in what house. All right, so this would be an observational study. Okay, and because it's an observational study, you cannot conclude that the size of the house affects the likelihood of recovery. So to answer the question is, you would say no. So it seems like experiments are better than observational studies, right? Because in an experiment, you can conclude that the treatment affects the outcome or the treatment causes the outcome. Whereas in an observational study, you can't. So should you always do an experiment? Well, the answer is complicated. Let's go back to that example of whether smoking affects heart disease. What would an experiment look like in that case? Well, an experiment would be, I would take a group of people, divide them up into 2 groups, and then I would tell one group to smoke for the next 5 years, and the other group to not smoke for the next 5 years. What's the issue with that? But the issue is, if smoking is in fact harmful, then I can't just force a group of people to smoke for 5 years, right? It's unethical for me to do that. So in that case, I would probably have to do a observational study. Same thing with example 4 here, right? With the size of houses. I can't really force people to live in a small house and then another group of people to live in a large house, right? I don't have access to houses to put people in. So in this case, I would probably have to do an observational study also. So if you have a choice between observational study and experiment, you should choose experiment. But you can't always do an experiment, right? Either for ethical reasons or there's no good way to set that up. And sometimes you do have to do an observational study. Okay, so let's talk about the different types of observational studies. So these all have to do with when you collect data. A cross-sectional study, the data is collected right now. in the present. Let me give you an example of this. So say I'm interested in whether age is related to level of exercise. So what I would do here is I would get some people who are under 18, some people from 18 to 25, some people from 25 to 35, some people from 35 to 50, some people from 50 to 65, and then some people who are over 65. And then I would ask them all what their exercise habits are, right? So I'm collecting data on across these age groups all at once right now, okay? All at the same time. So that's an example of a cross-sectional study. A prospective study, the data is collected in the future. And as an example, so same study, age and exercise. What I would do for a prospective study is I would start with a group of people who are under 18, like young people. And then I would follow them as they age, right? So I would follow them into their 20s and then ask them about their exercise habits. Follow them into their 30s and then ask them about their exercise habits. And then follow them into their retirement and ask them about their exercise habits, right? That's a prospective study. A retrospective study, you're collecting data about the past. Okay, and same example with age and exercise. For a retrospective, I would start with, say, people in their retirement, so people who are over 65. And then I would ask them about their exercise habits in their past. So I would say, okay, in high school, what was your exercise habits like? And then in college, what was your exercise habits like? And then in your 30s, what were your exercise habits? Okay, so those are the three main types of observational studies. Let's take a look at some examples. So part A. Samples of subjects with and without heart disease were selected. Then researchers looked back in time to determine whether they took aspirin on a regular basis. So the thing that jumps out to me here is look back in time. Right, so you have some people and you're asking about in the past, did you take aspirin or not? So this would be retrospective. Part B, researchers from the National Institute of Health want to determine the current rates of marijuana consumption among adults living in states that have legalized the use of marijuana. They conducted a survey of 500 adults in those states. Okay, so you have people, you're not really asking about their past, right? You're asking them, do you use marijuana right now? You're not following them into their future. So this would be all right now in the present, cross-sectional. And in part C, a recent study compared the heart rates of 19 infants born to non-smoking mothers with those of 17 infants born to mothers who smoked an average of 15 cigarettes a day while pregnant and after giving birth. The heart rates of infants at 1 year, 2 years, and 3 years of age were measured. Okay, so you start with the infants, and then you follow them when they're 1, when they're 2, and when they're 3, right, into the future. So this is a prospective. Okay, so let me talk very briefly about section 1.4. Okay, so remember, we want to know about the population. So say I want to know the mean of the population. The reality is I can't get data from everybody in the population. So my next best thing is to take a sample and then find the mean of the sample. And my hope is that the sample mean is close to the population mean. Okay, that's our goal. So if your process or procedure results in the sample number being close to the population number like you want, that process is called unbiased. That's what you want. Now, if your process or procedure results in the sample number being way off compared to the population number, that process or procedure is called biased. And what we have here is just a list of ways that you can be biased. So these are all things you should not do, right? Because it'll lead to a sample number that's way off compared to the population number. So some of these we talked about already. So voluntary response samples, response bias, comes from a voluntary response sample. So this is, remember, a situation where you set up like a website, like a review website, and then people choose to go to the website and then write a review. And we said the problem with this is that the people who choose to go to these websites and write a review are often people who are either super happy or super pissed off. So you don't get a good representation of the full population that way. And then just read through the rest of these and don't do these things. So I think that's all I have for you today. Have a good day. I'll see you in the next video.